Welcome back everyone, Patrick here, moving on to another question dealing with quadratics. So we have to create examples of quadratics in standard form with either two x-intercepts, one x-intercept, or no x-intercepts. So usually we're given quadratics and we have to work in finding the x-intercepts. Now we're going backwards. We have to create some examples. So starting with part one, if a quadratic has two x-intercepts, it means it's going to cross the x-axis at two different points. So there's different ways that these could look. It could look like this, it could maybe look like that, or maybe it could be pointing down, right? Opening downwards like this. Doesn't matter. Point is that all of these cross the x-axis twice. And so because we have to provide them in standard form, sometimes you could start off either with factored or vertex form. So with the 2x-intercept, I'm actually going to make a quadratic that starts off in factored form, let's say like this. Right, so from here we could tell there's an x-intercept at -4, there's an x-intercept at 3. Right, two of these factors here. And so if they want it in standard form, what we have to do is we got to expand this. So this would end up being x squared plus 4x minus 3x minus 12, which would give us x squared plus x minus 12. Right, so there is an example of a quadratic that has two x-intercepts. And then these factors, they can be anything. As long as they're different, both of these, over here, then it's going to ensure that you have a quadratic that is crossing the x-axis at two different points. You could also put some kind of value in front. So if we had maybe like -5, let's say 2x plus 3, x minus 1, for example. Right here, there's an x-intercept at -3/2. Here, there's an x-intercept at 1. And so what you would do is just expand this, -5, 2x squared. This would be minus 2x plus 3x, which would give us positive x, and then we'd have minus 3 like that. And then we could distribute the -5 into the bracket, and there we have a quadratic that's in standard form. So this is going to have two x-intercepts as well. Right, so an infinite amount of examples. That's typically how I would do it. I would start with factored form for this case and then expand it into standard form. Now, what if a quadratic has one x-intercept? Well, the only way a quadratic can only have one x-intercept is if that x-intercept is the vertex, right? So something like this, for example. Right? Or maybe let's say something like that. The only way a quadratic can have one x-intercept is if the vertex is that x-intercept. And remember, this case, it's also a quadratic that ends up being a perfect square trinomial. Right? If you remember, it only has one factor and it's going to be squared. So for example, something like, let's say, x minus 6 squared, like that. Notice that the x-intercept there is positive 6. It's opening upwards because there's like a positive 1 in front, so it would be like that, right? So this is an example of a quadratic with one x-intercept. Now if we expand this, it's like x minus 6 times x minus 6, which would give us x squared minus 12x plus 36, like that. Right, so that's standard form. A standard form quadratic that would have one x-intercept. If you graph this here on Desmos, you would get a graph like this. Then we could also have some kind of value in front if you want to, whether a positive or negative. If it was a negative, it would look like a quadratic like this that's opening down where the vertex is a maximum on the x-axis. So again, a bunch of different ways you can do it, but here is an example of a quadratic with one x-intercept. Now, no x-intercepts. For this case, I feel like it's a little trickier to, well, first off, it can't be factored, right? Because there would be no factors because there's not going to be any x-intercepts. So with this kind of case, what I would do is I would actually pick or choose a quadratic, write it in vertex form, and then expand it, because it's basically going to be either a quadratic that's above the x-axis and is opening up, right? Or it's below the x-axis, the vertex is below, and it's opening down, right? Notice that this vertex, if a quadratic has this vertex, it can't be opening down because then it would cross the x-axis twice. Or if this quadratic was opening up, right, it would cross the x-axis twice. There can't be any x-intercepts. So you either pick a quadratic with a vertex above the x-axis, right, and then you have to make sure that the a value is positive, so it's opening up. So for example, if we picked, like, let's say 3 and 5, right, 3 and 5 for the coordinate of the vertex, then we just have to make sure we have an a value that's positive. So this quadratic is opening up, so it's never crossing that x-axis. Or here, let's say this was like -4, and then let's say this was, I don't know, -2, right? So -4, -2 would be this vertex, and then you got to make sure that that a value is negative, so it's opening down, right? So you either pick a quadratic with a vertex above the x-axis, opening up, or a quadratic below the x-axis, the vertex below the x-axis, and it's opening down. So for example, this here, we can go like y equals, let's pick a positive a value, let's say 2, and then we'd have x minus 3 squared plus 5, so we put it in vertex form, and then I would expand all of this because we have to get it in standard form, right? So it would be 2x squared minus 12x plus 18 plus 5. Those are like terms at the end, 23. So here is an example of a quadratic in standard form that would have no x-intercepts. If you plot this, you'd end up getting something similar to that, where it's not going to be crossing that x-axis. But we started it off with the vertex form, picking a vertex above the x-axis, 3 and 5, and then making sure that the a value is positive. Now, what about here? Well, we have a vertex, -4 and 2, so it'd be like x plus 4 squared and then minus 2, right? The k and then the h and the k value in the vertex form, but then the a value has to be negative. It has to be opening down, remember, right? If that vertex is going to be below the x-axis. So we could pick, let's say -1 would be an easy one, but you could pick -2, -0.5, you could pick whatever negative number for that a value to ensure that this quadratic is going to open down. You could have also maybe picked a vertex over here, so like, let's say 3 and -2, right? Make sure that it's opening down. Infinite amount of combinations. So here, what would happen? -x squared plus 8x plus 16 minus 2, and then distribute the negative inside the bracket. You'd end up with -16 minus 2, which would give us -18, like that. Right? So there is an example of another quadratic in standard form that would have no x-intercepts. It would look something like that. Okay, so that's my personal process for doing these kinds of questions where you have to give examples of quadratic.